Memory, ROM, RAM and virtual. So RAM is random access memory and it's high speed. Now this is the main memory in the computer and it's where all programs, files and data are stored while they're being used. Okay, so it gets copied off the hard drive onto RAM and then the computer can use it. But it's volatile. So because when the power goes off, any data on RAM gets wiped, think of it as like an Etch-a-Sketch. You can draw an amazing picture, so someone's drawn the Taj Mahal there. As soon as you shake it, or you're violent with it, volatile, violent, think of it, link the two together. As soon as you shake it, that picture is gone. Okay, it's exactly the same with RAM. As soon as the power's off, everything's gone. That's why we usually say, turn it off, turn it back on again. It's a bit of a computer science joke, but the idea is that by turning it off, you're just clearing RAM and then you're starting again. That's why it works. ROM, read-only memory. This is a small chip on the motherboard and it tells the CPU how to boot up, and we call this the BIOS, the basic input-output system. Now most people will never see this, but the idea is this little chip gets everything started. It's the first place that the CPU looks. And this is non-volatile, it doesn't change every time. Its job is to show the CPU where the operating system is, basically. Once it's checked everything's working and you've got memory plugged in and you've got your graphics card plugged in, it's done all those health checks, it says where the operating system can be found. And if that changed every time, it'd be pretty useless. So this is non-volatile, it doesn't change. You can update them, and that's called flashing, you can do that, but it's very rare. So what happens on boot up then? Usually we just turn our computer on and then within a couple of seconds we see the Windows logo or we see the iOS logo. But what goes on underneath that? So the CPU reads instructions from the ROM, because the ROM's got the instructions on what's happening. The ROM tells the CPU to perform a self-check. So is the memory plugged in? And if you ever don't do this, but if memory's not plugged in properly in the computer, it will beep at you. And there's different beeps for different error codes. If you haven't got a hard drive plugged in, it will tell you that, because it's going to need those things. ROM tells the CPU where to find the operating system, so that's secondary storage. And the operating system then gets copied into RAM. So when the computer first turns on, the CPU goes to ROM. And the ROM says, right, we need to do a health check first of all. Is everything connected? Have we got memory? Have we got graphics cards? Everything's ready? Yep. Its second job is to find the operating system. And ROM knows that the operating system is stored on the hard drive, because at this point RAM's empty. The operating system then gets copied onto RAM and read back into the CPU. And that's when the fetch execute cycle starts. It's going round and round and round. So the first part of the operating system gets copied into RAM, then the CPU requests the next bit and the next bit, and it gets copied across. And then, then the files, so let's say Office is stored on your hard drive, that gets copied onto RAM, and that goes to the CPU. And it just keeps going round and round and round. But the first port of call, CPU goes to ROM, ROM checks everything's working. Where's the operating system? It says it's on the hard drive. It gets copied off the hard drive onto RAM, and then it goes into this loop, the fetch, decode, execute cycle. Virtual memory. Computers only have a limited amount of RAM. Okay, so we can't store everything in RAM, and RAM gets full with data. When this happens, we've got an issue. If RAM can't hold anything, in theory, we then have to start closing programs down. Well, what happens if you want to do a bit of Photoshop and the emails, you want to have everything open at once? This is where virtual memory comes in. So virtual memory isn't real memory. The secondary storage gets used as memory for items that have not been used for a while but are open. So let's say I've got my emails open, but I haven't checked them in a while. A section of the hard drive gets allocated as memory or virtual memory. It's kind of like pretend memory. And anything that's not currently being used gets copied onto virtual memory. If the CPU needs that data, it gets moved back in RAM. This is slower than just using RAM. So it's kind of like a backup. It's like, RAM doesn't need it, you haven't used it for a while, so we'll put it in the hard drive to use RAM, so that frees up a bit of space in RAM, which is faster, but obviously it's going to be slower then if you then decide to, I want to use my emails now, I want to check that. that application has got to be copied back into RAM and then booted to the CPU. So that's why it's slower. But just think of virtual memory as not real memory, it's just a part of the hard drive that gets used as memory, but it is slower.